Hello children, let us continue refraction of light. I have finished in my earlier classes refraction of light, laws of refraction. Then I have finished the principle of reversibility of light. Then I have finished the after that I have finished lateral displacement. Then I have finished multiple images formed in a thick mirror. Okay, so these all I have finished. Then I have also finished refraction of light through prism. Right, now I am doing part C, that is simple applications of refraction of light. Now often you must have observed of refraction of light. See children, now often you must have observed that when you place a pencil or a stick in a beaker having say water, okay, so suppose a beaker is full of water. If you keep a pencil inside the beaker, when there is no water, the pencil appears like this, but the moment you pour water, the pencil appears bent or the pencil appears raised, isn't it? So the reason for this or the principle behind this is the uh, phenomenon of this refraction of light. Now I'll explain to you. Another example which is a very common phenomenon which observe is, suppose if you in a big, again in a vessel or in a transparent vessel, if you say, suppose this is a transparent vessel, suppose here you keep a coin. Now, even that there is no water, and when you view from outside, it appears the coin is at the base of the vessel. But the moment you pour water, you will observe, you will feel that the coin is raised. Okay, so all these examples can be explained with the help of this principle of refraction of light. Okay, so let us start in detail first. Now, suppose you have PQ is the surface separating two media, that is you have water here, okay, which is the denser media, this is the water, okay, and here you have air which is rarer media, right? Now suppose you have kept an object O, suppose this point O, you have kept an object, right? You have kept an object in the water, right? Now, so the real depth is this. This is the base of the vessel or wherever you have kept. So, this is the real depth, right? Now, you have kept the object here at point O. Now, suppose a light ray from the object strikes at 90 degree and goes undeviated, right? 90 degree it goes undeviated, okay. So this is one light ray which goes undeviated. Say OA is the light ray which after striking the surface, since it is striking at 90 degree, it goes undeviated as AA dash, right? Now other light ray from the object strikes the surface of separation, say at an angle of I. From here it starts. Now suppose this point, you call this point as say B. Now here the light ray is traveling from a denser medium water to a rarer medium air. So it will bend away from the normal. Okay, do you remember that? Okay. So now if this is the normal, NN dash, say if NN dash is the normal, this light ray will bend away from the normal, right, making an angle R with the normal at that point B. Now, if you view from here, if you are going to view from here, then what will happen? You will see actually the light ray, you will feel as if it is coming from the image of the object. Why? Because when you produce the refracted ray backwards, it will meet the other light ray OA, that is at this point the virtual image I of the object O is formed. So you will feel that you are seeing the coin. Actually, you are seeing the virtual image of this object O. So here you will be seeing, instead of here, you will feel the light rays coming from the refracted rays coming from this point, which is the virtual image of the object O. So this is called, this IO is the, that is what I was telling, it looks raised. Suppose if at O you have kept a coin, it will appear as if the coin is at raised to point I. So this IO, this is the difference in the real and actual depth. So real depth is this part and apparent depth is this part where the object till I. Okay, so this is the apparent. Apparent means which is not real. Real depth is this AO, and AI, real depth is AO in the diagram, and apparent depth is the false depth, okay, or which you are seeing. Okay, so that apparent depth is AI in the figure. So real depth is more, apparent depth is less. And what is this IO? IO is the shift in the position of the object. It appears as if it is shifted from O to I. Okay, is that clear? So this is the reason when we place a coin in a beaker, glass beaker, and we view and we pour water and we view from the top of the beaker, the coin appears to be raised. Okay, this phenomenon is because of refraction of light, right? Is the concept clear? Now we need to calculate the real depth. If you know, you can calculate the apparent depth, and you can even calculate the refractive index of the medium with respect to air using the real depth and apparent depth. So the relationship between the refractive index mu of the medium, here it is water, with respect to air, okay, then the real depth, what is the real depth here? AO, right, and apparent depth. Apparent depth in this figure is AI. Okay, so the relationship between these three is mu of the medium, that is refractive index of the medium, with air, with respect to air, is equal to real depth upon apparent depth. Sorry, it is APPARENT. Okay, apparent depth. Now in this figure, that is what this implies. This implies what? As per the figure, this implies mu of the medium with respect to air. What is our real depth? AO. And what is the apparent depth? AI. Okay, AO upon AI. That is in the, as per the diagram, right? So now if you know the real depth, if you know the mu of the medium, then you can find out the apparent depth. Any out of the three quantities, if you know any two, you can find out the third. So small numericals you may be asked related to this formula. Okay, so this formula you have to remember. Okay, now other formula from this they can ask, what is the shift of the object? So shift of the object will be real depth minus apparent depth. So what is the shift in the figure? In the figure the shift is OI, right? So real depth minus the apparent depth is the shift. Now till here is it clear? Okay. So now with on the same basis we can explain the bending of a stick when immersed in a vessel containing water. Okay. Now these diagrams are very important. They ask you to explain the bending of a stick due to reaction with the help of a diagram. They may ask you show how a coin will appear lifted when placed in a transparent vessel containing water. Okay, so these are the different types of questions which they ask. So you have to learn to draw the diagram. For example, I will show you the bending of a stick under water, apparent bending. Actually, the stick or the pencil that you are keeping is actually not getting bended, but it looks to be bended, apparent bending. Okay, so let me draw the diagram, which is very important. This is a very important, very important question from your examination point of view. So they will ask you, explain the question usually asked, explain the apparent bending of a stick under water with the help of a diagram. Okay, so now I will explain you. Suppose this is the surface of separation. This is the vessel containing water. Okay. Now above the water you have air, and this is the denser medium, that is water. Okay. Now suppose a stick is kept in this water like this. Suppose this is the stick which is kept. Okay. Now suppose, and now you will see from this stick light rays are coming up and they pass through the water, they enter the air and then they reach our eyes. So now let us consider two light rays. Suppose this is the tip of the stick, say let us call P. Okay. Now from this P, say two light rays are coming out. Suppose one light ray is coming and striking the surface of water, and like this, and another light ray is coming and striking it here. Okay. Now again the the light ray is passing from water to air, that is from denser to rarer. Each light ray will bend away from the normal at the point of incidence. So this ray will bend away from the normal if this is the normal here, and this light ray also will bend away from the normal, right? So if these refracted rays, now suppose you are viewing from here, from the top. Okay, so this is the eye. Sorry for the artistic skills, I am not very good at drawing the eye. Okay, so this is, you are viewing from here. So now these are the refracted rays, right? Now when you produce them backwards, they meet at say P dash. So this point P dash is the image of the point, virtual image of the point P. right? Do you follow? The refracted ray appears to meet when you are producing them behind. So that is a virtual image. So when you view from here, you appear as if you feel, it appears to you or you feel that the tip of the stick is not at P but at P dash. So till here the stick is appearing to you. So you will feel the stick is like this inside the water. The tip of the stick is this. So the stick appears bent here or raised here, right? And it appears here. Okay. So as if the stick has got bent here. That is called apparent bending of the stick. Okay. Is it clear? So this you will have to practice the diagram. Okay. You will have to explain only with the help of a diagram. You need not discuss it in theory. Is it clear? Yes, children. Let me proceed to. So now let me discuss, or before that, let me show you how a coin appears raised. Okay. When a coin is placed in a it appears to be raised. Okay. So it is also similar to this only. Suppose you are, sometimes you are also asked the same question, like for example, I remember this question is asked in this manner also. You will be given this diagram like this, okay, and you will be told that this is a pencil kept in a glass beaker or vessel, and show with the help of a diagram how the pencil will look when water is poured in the vessel. So same diagram, you have to complete the diagram. You have to draw and then complete the entire diagram. Okay. Now another question they may ask, that and this is explained, or they say complete the diagram to explain to explain the bending of the pencil, or sometimes they say what changes will be observed in the appearance of the in the appearance of the pencil when viewed from above. Explain only with a diagram. Explain with a diagram. Okay. So in these questions you have to draw the diagram only. Okay. So now similarly, suppose again same thing happens. Suppose you have a beaker, you have water, okay. So here suppose a coin is kept at the bottom of the vessel. So when you again same thing, two light rays reach the surface, they since they are going from denser to rarer, both will get bend away from the normal. Now if you are viewing from here, there you will appear, the coin will appear somewhere here, the virtual image of the coin. So for you, the vessel looks lesser in depth, isn't it? Actually, the real depth of the vessel or real depth of water is this, whereas the apparent depth only you feel as if the this is the depth of the vessel, because you are able to see the coin somewhere here, because this is where they are meeting. Okay, so this is the apparent depth. So this is a coin placed in a vessel containing water. Okay, is that clear? If the object is here coin, it will appear here at P dash. So it will appear raised. So you will feel that the depth of the vessel is less. Okay, clear children? Okay. So let me discuss some more consequences of the refraction of light. Now, in our daily life, we come across many phenomena actually which are caused by the refraction of light. Now, one of them is a star appears twinkling in the sky. A star appears twinkling in the sky. So, this is because of, again, because of the change in the refractive index of air with temperature. Now what happens with the light ray which is coming from the star and reaching our eyes is passing through different layers of the atmosphere, different layers of the air. Now, the different layers are at different temperatures. So, because of that, the layer which is at a higher temperature, the layer of air, becomes rarer than the air which is at a lower temperature. It becomes denser. So, wherever there is this, whenever the light passes through these rarer and denser medium or denser to rarer medium, what is happening? The light ray is undergoing refraction every place. So because of this refraction, we are able to see the multiple images of the star formed. So because of that, we feel as if the image is shifting or the star is twinkling in the sky. That is the reason. Okay, so if you are asked why does a star appear twinkles in the appears twinkling in the sky, or stars twinkle in the sky, what is the reason, or give reason. So you have to write the because of the change in the refractive index of the air with temperature. Okay, you need not explain in detail, but did you understand why it happens? Because of the change in temperature, the air becomes denser and rarer. The light ray traveling passes through different denser and rarer medium, and at every place it undergoes, there is a bending of the light ray, so because of refraction. So that is why we see the image of the star, and because of the shift in the image, we feel as if the star is twinkling. Okay, so give reason. So what will you write? Because star appears twinkling in the sky because because there is a change in temperature of the various layers of atmosphere, and as a result there is a change in refractive index. As a result there is a change in the refractive index of the different layers of air. Okay, did you understand? Actually what happens because of the refractive index, changes in the refractive index means what? There is the atmosphere is has forms as if denser and rarer medium, because where the air is at a higher temperature the air becomes rarer. Okay, and where the air is at lower temperature it becomes denser. So because of the change in this medium, because of this rarer denser medium, what happens? The light ray coming from the star undergoes refraction and we see the image of the virtual image of the star. There's a change in the refractive in the different layers of air, and we see the virtual image of the star, and it gives a feeling of twinkling of the star. Okay, then the sun, see, when it is seen a few minutes before it rises above the horizon, in the morning, and also in the evening few minutes longer after it sets. Like what? Before the sun has actually risen completely above the horizon you can start seeing the sun, and also when the sun sets, the sun has set but you can still see it for a few minutes longer after the sun sets. Again the reason is same, refraction of light. Then as I already discussed with you, a coin kept in a vessel appears to be raised. When you view it from the top, it appears to be raised when water is poured in the vessel. Okay. Then a print appears to be raised when a glass slab is placed over it. Now on your textbook, if you click a glass slab on the printed content, the print appears raised, the letters appear raised, again because of the same refraction. Then a piece of paper stuck at the bottom of a glass slab appears to be raised when seen from above. All the reasons are same. A tank appears shallow than its actual depth when viewed from top. Again same thing, because of refraction of light we see the virtual image, and so we think the apparent depth is the real depth. So the tank appears shallow, and a person's legs appear to be short when standing in a tank, or when you sit on the river bank and when you dip your feet inside the water they appear to be short. Why? Because of again this refraction of light. Okay, so we have learnt about twinkling of stars. We have learnt that the sun appears for longer after it has set, and also it appears before it has actually has risen, and a coin kept in the vessel, and we have discussed the print appears raised when a glass slab is placed over the printed content. Then a tank appears shallow when viewed from from the top, and a person's leg appear to be short when standing in a tank containing water. Okay, so all these are consequences of the phenomenon of refraction of light. Okay, is that clear? So can I stop here, because the next is part D, where I will be discussing about critical angle and total internal reflection. So let me stop here. You practice the diagrams and we will meet in the next class with the part D, that is critical angle and total internal reflection. Thank you children for watching.